Hello, welcome to the second seminar of the Digital Classicist London Summer 2025 series here in person in London and live on YouTube. So today we have Valentina Lunardi from UCLA, who's also currently a visiting PhD student at KCL, and Barbara McGillivray from KCL talking about static and contextual embedding for tracing semantic change, the case of Christian Latin. And I'll hand straight over to Valentina.
Thank you, Casey.
To start.
Okay, so let me share my slides. Well, before we get started, I just want to point you to this QR code, which is essentially a link to a copy of these slides, which I think and there should also be a link in the comments, I think. So you can if you want to look up the slides at your own pace, or you miss something, that's an option for you. So let's jump in. And I thought I'd start us off by sort of addressing all of the main themes that are in this title, right? So we've got some big words here. We've got embeddings, we've got semantic change, we've got Christian Latin. So I thought we'd go all over those things so to make sure that we're all on the same page. Forgive me for starting off from semantic change, as my training is that of a historical linguist mainly. So I'll tell you, I'll contextualize why I'm looking at this question, starting from this. Okay, so I'm sure we're all familiar with what semantic change is. It's obviously the change in the meaning of words over time, and here are just a couple of examples. So, for example, Old English mete meant food, and that same word, which is now pronounced slightly different, meat, in present-day English obviously means something slightly different, meat. And that's an example of what linguists would call narrowing. And something quite opposite happened with Latin salarium, which meant something quite specific. It was sort of used to refer to a soldier's allotment of salt, and eventually came to mean wages. As the allotment of salt was used as a form of wages. And that's, normally referred to as widening. All languages have evidence of this phenomenon. It's quite extensive, in fact. But despite its ubiquity, semantic change is sort of a sub-branch of historical linguistics that's normally considered a bit like the black sheep of the family. Why is that? Well, normally across those sorts of textbooks and papers, we find quotes of this kind. This is a bit on the extreme end, but effectively what people tend to think, this kind of view is quite spread, that if you attempt to have any kind of systematic study of semantic change, you will fail. You'll end up failing because semantic change is essentially patternless. The belief, the reasons behind this are, I think, multiple. We can sort of split them up into two. I think one of them is the fact that the motivations behind semantic change are, in a way, numerous. They're varied. Often they're extra-linguistic, like depending on cognitive factors or sociocultural transformations. And the other issue is that the method available to trace semantic change is very slow. So essentially what we've got so far is, if you want to find out about the history of a word, and you deal with, for example, like in lexicography or something, you just have to read, you have to trace the meaning of that word across time through close reading of text. So if you think that each language has tens of thousands of words, you can see how it's quite difficult in a way to find trends of change if you go down this route. So by contrast, I always bring this comparison. So if you think about sound change, which is a very well theorized subfield of historical linguistics, the average number of sounds in a language is about 30, right? So you see how with that kind of size of data, it's much easier to come up with trends of change. So why am I telling you all this? So I'm telling you all this because I think there have been lots of changes, as I'm sure you're aware because you're in this seminar lately. which have to do with a bunch of different tools that we have available to analyze the recently digitized textual data. And the development of all these kind of quantitative, statistical, and even machine learning tools have included also the development of methods to detect semantic change, try and detect semantic change within diachronic corpora. Normally, this kind of push has come from people who have to do more with sort of computer science than linguistics, and it's motivated by sort of the desire to provide data-driven linguistic knowledge and try and apply an interesting modeling tool to a complex, temporally evolving data type. But I think that, or at least this is not exactly my goal, but it's certainly a motivation behind why I'm looking into these methods. I think eventually these methods might have an impact on the theory of semantic change. So again, forgive my point of view of a linguist here, but that's sort of the motivation behind looking into this. So even though that's not, my goal, revolutionize the theory of semantic change so far, I can definitely sort of contribute to the field in the form of, trying and testing and refining the methodology, especially for historical under-resourced languages. And we can also try and contribute in the form of data about change within a specific language that will eventually, hopefully help the people who want to deal with the theory of semantic change a bit more. Okay, so that's parenthesis closed for linguistics. And we'll focus today on, obviously, word embeddings. As you know, that's in the title. That's the method that we're looking at today for detecting semantic change. For those who are not familiar with word embeddings, the fundamental ideas behind them are as follows. Like, they are, on the one hand, we've got the distributional hypothesis, which is sort of an offshoot of what's known as distributional semantics. It was very popular in the 50s, and then was eventually supplanted by formal semantics. But it had, some success within corpus linguistics and computational linguistics. And the distributional hypothesis essentially tells us that two words are as similar between themselves as the context they're in. So that's one of the cornerstones. And the other idea behind word embeddings is that we can represent words as vectors. So these two sort of ideas put together, put simply, have given birth to word embeddings. And here is a very trivial example provided by Barbara, where we're basically trying to find vectors for four words: strawberry, blackberry, blueberry, and computer. And how do we do that? Well, originally in the very, very early count vector models, and the most useful for examples, we would sort of count the co-occurrences of each of these words with the other words in whatever sentence or text you're looking at. So, for example, strawberry in a hypothetical set of sentences that we're looking at co-occurs with all 9 times, with eat 6 times, with nice 5 times, and so on. And all of the numbers in the row that you see will be essentially the vector coordinates for strawberry. And so if you try to sort of squish it down to 2 dimensions, that's what you would get. And we're trying to represent the vectors for strawberry, blueberry, blackberry, and computer. This is what you would see. On the sort of horizontal axis, you see the count for the co-occurrence with these words and nice, and the vertical axis corresponds to the co-occurrences with these words and phone. So as you can see, sort of the vectors for blueberry and strawberry are quite close to each other, and they're very far from the vector for computer. And blackberry is somewhere in between. Why do you think? Why do you think that might be? The answer would be obviously, because BlackBerry at some point was the name of a phone model. So you can. It's obviously a fruit as well, so it's somewhat close to the fruit words, but also close to the computer word. So that's kind of the basic fundamental idea behind embeddings. Now, the field has moved forward quite a lot. I mean, obviously, as you might know, word embeddings are the core idea behind large language models. So that gives you sort of an idea of how much forward the field has moved. But these newer models still use vectors to represent the meanings of words. But these coordinate values are found automatically through a process called training, which is subject to certain preset parameters, which vary according to the type of model that you use. So you might have window size for occurrence, the maximum frequency of a word for it to be included in training, how many times you want the model to go over the data, so that's epochs and learning rate, and so on. While in these earlier models, the coordinate values were very easy to interpret, they're essentially equivalent to frequency counts, these newer models don't make it so easy for us to interpret the coordinate values at all. One thing that's often suggested is to sort of think about it as if each value is representative of some property of the word, but in practice, these properties are not really interpretable by humans. But something that you could think of just to understand the concept is that maybe blueberry has a sort of higher value for the coordinate representing its fruit-like qualities, but a very low value for one representing its text-relatedness. The result found in the end is the same. What we want is for words that appear in similar contexts to have similar values and so be close in space. And this is a classic sort of picture for the static embedding models, where you see certain words that that are similar being close to each other, or appear in similar contexts that are close to each other. It's limited at that. So as promised, I'll look at the two basic types of embedding models, the earlier static models and the sort of slightly newer contextual models. For static mod, the basic difference are, as you can see, some of them are in this table. The static models output only one vector per word type. So that means that if you have like the word for dog appearing 100 times in your corpus, you will only obtain one vector for the word for dog. But contextual models will produce one vector for each time that dog appears in your corpus. So you'll end up with 100 vectors for the word for dog. What does that mean in practice? Well, it means static embeddings cannot deal with polysemy. So if a word has more than one meaning, you still get one representation for that word. But for contextual embeddings, they can pick up on polysemy. So if a word has more than one meaning, they'll be able to detect it, technically speaking. So the next row is just some names of famous models. So, for the static word2vec, fasttext, glove, you might have heard of these, and for contextual models, BERT, GPT, these are essentially large language models. Now, some more differences. The static embeddings need sort of a large but not too large amount of data, and the contextual models need a really large amount of data, which translates into the static embeddings be quite easy to run on your laptop. They're computationally lightweight, but the contextual models are really quite demanding, and you might need access to supercomputers and all that. So here is a sort of visual representation of what I've just been saying. So if you were interested in the word for bread in Latin, panis, for a static model, you would just get one vector for it, one representation in space, and you can sort of use that to see what the other words in the same area of space are. But on the right, you see instead a plot of all of the instances of this word. A plot of all of the embeddings for all of the instances of this word, if that makes sense, which I've just isolated. There are no other words represented there, it's just the one. So you get lots of vectors for it. Now, let's sort of narrow down a little bit and say, okay, I've talked to you about all these embeddings, but how do you use them for semantic change, right? Well, the fact that these words have a spatial representation, they're now essentially numbers, right? So we can quantify the difference between two words by comparing their vectors. And a very popular function that's used for this is called cosine similarity, which essentially, well, it's a bit more complicated than that, but it calculates sort of the cosine of the angle between two vectors, and that gives you sort of a distance measurements between the two. You've got this value range from 0 to 1, and 0 means no similarity at all between the two vectors, and 1 is, the two vectors are identical. There are some other functions as well that you can use, and we might address some of those later, but just be aware that this is not the only one, but it's a very popular one. So obviously for semantic change detection, the idea is that you can compare vectors for the same word, but where the vectors are calculated from separate sets of documents from different timeframes. So if you calculate the vector for dog in a certain time frame, and then the vector for dog in a certain other time frame, you can compare those two vectors and see if those two vectors have changed. How distant are they? The other thing you can do, and that's more for a bit like qualitative assessment, is see how the vectors of a target word relate to the other vectors in space. So if the relationships change across different sets of documents, then that might signal a change in meaning, or at least in usage. Okay, so I'm using now. Let's get to the meat of what I'm using these methods for. I'll go very quickly over this, but the idea is to look into Christian Latin. So obviously, the spread of Christianity had an effect on lots of things in the Western world. Politics, society, culture, and obviously also the languages through which it's spread. So the fact that Christianity had influence on Latin is generally sort of unchallenged, and many of the lexical phenomena within Christian Latin are a result of influence from Greek, and you can see some examples down there. But there are plenty of native words as well that acquired a new Christian sense, and that's sort of what we'll be focusing on today. So this is right. There's a bit of a debate about Christian Latin as a linguistic entity. That's kind of debated over in the literature. I don't want to get into the details. I feel like that's a bit off track, but essentially there are two schools. One of them is called the Sondersprache hypothesis, where you've got people essentially arguing that the Christian community developed this unique register, this unique form of Latin that had its own morphology, syntax, and lexicon. And then some other people saying, okay, that's not possible. You're relying too much on specific authors, and the conclusions you've drawn from this are skewed. But what everyone agrees about is that Christian Latin, Christian texts do have a unique Christian vocabulary. So at least we know that's a safe area to look into if we want to try sort of and advance the debate a little bit. So all that to say, these are very sort of ambitious ultimate goals for my research. I'm not saying these are the goals for today or even for my PhD thesis as a whole. Maybe some of these will be answered there. But the idea is to try and leverage these new methods to contribute to the theory of semantic change and the study of the history of Latin, the debate about Christian Latin, and obviously further establishing digital humanities within historical linguistics and classics. But what we're going to do for the rest of today, now that we've got all of the setup and all the background to understand this, is we're just going to pick a couple of words for analysis that are typically considered like Christian or having undergone some change under the influence of Christianity. We'll talk about the corpus that I used and how I set up the various time slices and subcorpora, and then we'll compare and evaluate results obtained from the two types of embedding models. For the contextual embeddings specifically, I've fine-tuned Latin BERT, which is one of the few available large language models for Latin. Okay, and then we'll obviously conclude and discuss what might be done to improve this work, which is still work in progress. So the selected lexemes are, I mean, this you might have expected, but I mean, both of them you might expect. But Oratium is fairly, but not massively frequent in my working corpus. And in classical Latin, it can mean speech or locution, or refer to public speech or an oration, or even just mean eloquence. But in Christian texts, starting already in Tertullian, so very, I mean, the earliest you can get for Christian Latin texts, it starts meaning something like prayer. So we'll look into that. And this is an even more obvious word, but it's really good for illustrative purposes, so I hope you forgive me for that. But it's very, very frequent in my working corpus. And perhaps obviously with the advent of Christianity, it began to be used to refer to the Christian God in addition to referring to Roman gods. For as a corpus, I used Latinized, which is a corpus of Latin of approximately 13 million words, but I've reduced the corpus size to use only texts from 300 BC to 600 CE for a total of 6.8 million words. Why did I pick this date? Well, I wanted to sort of, the end date, 600 CE, depends on my willingness to just look into Latin while it was a living language. While the start date, I picked to try and make my pre and post-Christian time slices chronologically balanced, with the split coinciding, you know, with the very first attestations of Christian texts, or just before that. Not that I could have gone any further back, really, because then you get into the realm of fragmentary inscriptional evidence, and that wouldn't really help with the amount of data that I would add to this corpus anyway. There we go. I've set up, as I said, two time splits, one which should show no influence from Christianity, pre-150 CE, and the second one that contains lots of Christian texts. And that allows us to, as I was saying earlier, compare representations for the same words across the two time frames. Then for some further comparisons, I also created two subcorpora contained within the second time slice, so post 150 CE. One that contains exclusively sort of text with a Christian content, and the other ones all non-Christian content, loosely defined. Yeah, and that allows us to sort of compare the representation for the same word across different sets of text. And I thought that this might be helpful to try and understand whether the meaning of a certain word had changed, but had remained sort of specific to religious texts, or whether it had spread beyond religious texts. Okay, everything is sort of fairly balanced in terms of number of tokens, so that was quite lucky. For the starting embeddings, I started off with a code that Barbara had been working on, and the choice of model and values for the parameters in that code largely conform to the findings of these two previous studies. Well, 2/3, the one by Spurneri, Passati, Moretti, and Ribery and McGillivray. I'm using across all of my attempts lemmatized corpus to try and reduce variability, because yes, we do have a few million tokens, but it's still not an especially large corpus. So reducing variation in the forms the words can appear in helps. Fast text is picked here over the other models because it's been shown in one of these studies to be sort of more suitable for morphologically rich languages because it uses n-grams or subwords during training. And I tested a bunch of different parameters, sort of like window size, minimum frequency, which I had to sort of play a little bit more with, because sometimes I wanted to look into a word that wasn't frequent enough in the corpus, and so the embeddings weren't produced, and so on. Okay, so remember that for these models, you just get one vector per lemma, so one vector per word type. We're just going to run a simple cosine similarity calculation and compare what I told you we would compare. So word embeddings in the first time slice versus their equivalent in the second time slice, and the same ones again across the Christian and non-Christian subcorpora. We'll also have a list of sort of nearest neighbors to help us give a qualitative interpretation of everything. So starting off with Deus, we've got for the first time slice. I think for the first and second time slice, the results are quite clearly like picking up on the difference in meaning. So if you look at the nearest neighbors listed below, I just listed the first 6, but you can see some sort of typical associations or way to address God or the gods. In the first times, I see got immortalis, like the immortal gods, was a written way to address the Roman gods. Numen, which is like divine will. Dea, sort of indicating that there were also female goddesses, so polytheism, and then you've got Jupiter, name of the chief Roman deity. And for the second time, so you've got ways to refer to the Lord, Dominus, omnipotence meaning almighty, Christ, the creator, so definitely Christian associated terms. And I feel like for the second, within the 2 Christian and non-Christian subcorpora contained in the second time slice, we can see that for the Christian subcorpus, this association with Christianity is clearly confirmed, and for the non-Christian neighbors, we can see sort of a mix, I think. So that might show that the change spread beyond simply religious Christian texts. Okay, so that I sort of already told you about, so we can move on to the next word. We're starting embeddings, which is oratio. So we've got something slightly different here. I think for the first time slice, we have, again, associations with speech, perhaps something to do with legal action, something of that kind. And for the second time slice, I think we can see associations with different types, different means of communication, but no clear, except for confessio, association with Christianity here. So, but if we move on to the Christian and non-Christian subcorpus instead, then we can see, I think, for the Christian subcorpus, some association with Christianity, but not necessarily with prayer, I don't think. Maybe a little bit, some sort of weak association. And for the non-Christian corpus, interestingly, you don't get any sort of synonym or word that you would expect to appear, at least in classical Latin, with oratio, but you get associations with some particularly famous orators. So maybe we think that, I mean, my interpretation of this is that maybe it was used in a sort of educational context or text where you'd refer to people who were great orators. That's my take anyway, but you're welcome to intervene and tell me I'm wrong. I think I should have told you everything already. I forgot to mention the sort of cosine similarity score between the time slices, which was here 0.545, and for God, I think was 0.618. So there's a greater amount of change or of difference in usage in oratio than there is in Deus. But for the second time slice, it doesn't pick up on the prayer meaning. So that's interesting. Now, moving on to the sort of results for contextual embeddings. Sort of my starting point was Latin Bert, the large language model. Well, to my knowledge, the large language model sets trained on the largest amount of Latin among those available, approximately trained on 650 million tokens. I wasn't able to find more than one study that uses LatinBERT for semantic change detection. And the one paper that I found is very recent and looks into semantic change in medieval Latin charters. So this would also make my research here pretty new. Okay, so the idea for these large language models is that you don't normally train from scratch unless you've got access to really massive supercomputers, but you sort of perform some further training on them with your own corpus. If you want, you can also use them out of the box. But normally performance is improved if you do a little bit of further training, and that's called fine-tuning. So that's what I did, and I sort of fine-tuned LatinBERT on the same time slice of Latinized that I told you about, so 300 BCE to 600 CE, 6.8 million tokens. Again, I used the lemmatized corpus, and I tested a bunch of different parameters. I wish I had time to test more, but these tests take a really long time because it's not the kind of thing you do again on your own computer. You need access to some supercomputers, which I do have, but it still takes some time. So remember that for this particular model, you've got one vector per token. So however many instances of that word there are in your corpus, however many tokens you get. The consequences of this is that sometimes comparison across the subcorpora is not as easy because you've got way more things to compare them to. But the upside is that, as I mentioned earlier, now you can assess different usages or different senses of a word. So you can deal with polyphony. So some of the solutions that people have come up with for comparing these these vectors are, on the one hand, you could average all of the vectors per lemma, but again, that would mean that you end up with one averaged vector per word type anyway, and I'm not sure I see the point really of using contextual embeddings in this case. But the real advantage is if you go down the clustering route. So the ultimate goal of doing that is that you try and end up with vector clusters, with each cluster representing the different senses of a word. And well, it doesn't strictly need to be for form and target words, but this is one of the things that can be sort of a little bit heavy computationally. So what I've done is just sort of focus on a set of words and try and find clusters for those only to make things a little bit quicker. But again, the basic units that you want to compare are a bit less clear because, a word might have 2 clusters in one time slice and 3 clusters in another time slice. So what is it that we're comparing? But here are just a bunch of different similarity change measurement functions that I don't particularly want to go into right now, but I'll tell you what we will do. So obviously, as I said, we will try and attempt some clustering techniques using k-means and silhouette score. These are sort of big words that mean essentially I'll use some techniques to try and understand what the optimal number of cluster for each word is. And the silhouette score is supposed to tell you how close or how differentiated these clusters are between themselves. So if they're not very differentiated, then the senses are quite close, and if they're more differentiated, then the word is more likely to have quite separate meanings. That's kind of the basic idea. And then we'll try and we'll average each cluster to get one embedding per sense, and then compare each sense embedding to averaged embeddings. We can come back to this if I lost you by now. But essentially what we're trying to answer is this kind of question. So which words is the God sense of Dominus, so a word for Lord, close to? This is a bit unconventional, I think, but we believe it's kind of the most useful qualitative assessment for our purposes. So that's what we'll do. So for Oratio, these are the clusters for the first time slice. And put once again the neighbors, the sort of the averaged embedding neighbors underneath for us to try and give a qualitative assessment of this. The k-means that detected sort of 3 different classes to be the optimal ones. These are not sort of especially different, but I think there is maybe some slight, in terms of qualitative assessment, we could come up with some slight differences. Maybe so the first one seems to be more related to speeches in sort of the eloquence or the speech itself. The second one is more about orations, but these are loose sort of differentiations. And the third one seems to have more to do with sort of maybe legal related meanings the context, legal context in which you use an oration. These are some just pictures of what the clusters look like. It looks more like 2 than 3 to me from this picture, but this is a visualization techniques that sort of squishes everything down to 2 dimensions, and you might lose something there. But we trust the k-means to be right. Okay. For the second time slices, we've got 2 clusters instead. And I think this is where it gets interesting for this word, because with the static embeddings, we didn't pick up on the prayer meaning at all, but for the second time slice. But with the contextual embeddings, we do. So if we look again at the nearest neighbors, we see that I think for cluster 1, we've got only meanings related to speech, and for cluster 2, we've got Christian or meanings related to prayer and offerings and stuff like that. So that's good going. I think this is a picture of the classes. Something that I tried to do, which I thought might be interesting, is the following. So I tried to color up all of the so the red dots are all the embeddings that for occurrences of the word in text that I labeled as Christian, so Christian content, and the blue dots for anything else. So as you can see, I thought we'd get a spread that would pretty much match up with the 2 meanings, but we don't here. So that's something to think about. That's an interesting result. This slide pretty much says what I tried to tell you already. Okay. Now for Deus, actually the results are not quite as satisfying. I'll let you stare at it again. Sort of 3 optimal classes are detected here, but I think virtually they're no different from each other. And so that's kind of that's what I got. I'm not entirely sure why we've got 3 classes. They all seem to be really close. The silhouette score is quite low, so that would sort of confirm that these classes are not very well separated between themselves. And if you look at the plot for that, it all looks like one big, collection of dots, really. Maybe. Okay. For the second time slice, this is what we've got. And once again, I think the 2 classes are very close to each other, judging from the nearest neighbors. And so once again, that's these are questions to ask for me in the future. The silhouette score is a little bit higher, but yet again, if you look at judging from the nearest neighbor, so a qualitative assessment, again, you can't really. There's not much of a difference between these 2. You see both words related to Christian themes and non-Christian themes, like Roman religion themes. And this is what the plot looks like. So yeah, you can see a little bit more of a separation between 2 classes, but that might, I don't know, reflect something else. Okay, and here is the same sort of plot with the red dots and the blue dots, but it looks like maybe there's a bit of a concentration on the left of Christian text, but I mean, it's not much there. Okay, so for Deus, as I said, both in the first and second time frame, all of the clusters seem virtually undistinguishable, judging from the nearest neighbors. And so the questions one might ask is, these, I haven't had enough time to think about this thoroughly, but one question that I had is like, does very high frequency make it harder to have well-defined clusters for contextual embeddings? And if so, can you sort of try and scale things down a bit to get better results? And the other question I have is, how much does the pre-training on the 650 million tokens really influence the results for this particular time slice? So yeah, those are questions for me to think about in the future. But to sort of try and wrap this up a little bit is for starting embeddings, we had some, I think, good results for very high frequency words. I haven't shown you this, but in the past, I haven't obtained particularly good results for when a word was particularly infrequent in a corpus. So I'm just giving you that piece of information for completeness, even though I haven't told you about that today. And we saw that it was kind of useful to split the corpus into sex type as well to gather more fine-grained information. But otherwise, polysemy can be a bit of a struggle, and as we saw with the ratio, sometimes only the dominant tense is picked up. The upside is you can sort of set, with a bit of coding experience, you can set this up quite quickly, and you can test different parameters and train your own models in virtually not much time. But for contextual embedding, instead, we can investigate whether a word was polysemous and try to gather information about each of its senses with the clustering techniques. I haven't even sort of relied too much on text type, except for the plotting. I have still some questions to ask about these results. As I mentioned, do we potentially get less good performance with high frequency? Again, I haven't shown you low frequency words are still a little bit problematic, but not as bad as with static embeddings. And the massive, the big downside, if you want to sort of try this yourself, is that it's kind of a slow type of research. You need access to supercomputers, and testing different configurations can take a while. So yeah, I mean, some next steps for me is obviously sort of try and develop some benchmark and evaluate these results that we've looked at sort of qualitatively a bit more rigorously, and try and assess the shortcomings that we've seen. Obviously, it's ideal to advance the field by making the job easier for us, but it's also important that the final product is good. So refinement of technology is also important. Eventually, I want to look into some slightly simpler distributional methods as well, like locational analysis, but that's something for another day. So thank you.
Great, thank you very much, Valentina. And we've now got some time for some questions, both from people here in the room in London and online. If you're watching live online, do feel free to put any questions in the chat. And I see we've got a couple of questions here in the chat already. We've got a question in the comments from Kelly asking about the BERT model. Could you talk a little bit more about the BERT model and issues and potential biases? How might this impact research when working with a Christian Latin data set?
Yeah, okay. So what can you say about that? Right. So apart from the fact that I said, I can talk a little bit more about the fine-tuning process if you want, but that doesn't seem, what are the issues? So, I mean, one thing that's sort of generic to all embedding models, I think, is that I'm sort of getting to the weeds of what whether we can translate what these models are telling us into actual semantic properties, right? So what we're picking up on is obviously differences in the distribution of these words. Does that, I mean, the basic question is, does that only give us information about how these words were used, or does it give us a window into what these words actually meant? And this is a sort of a bit of a philosophical question that linguists have been asking. Actually, it's a bit of the problem at the core of whether we believe distributional semantics to be representative of how we learn language. So that's, sorry for going down this road, but like that's a bit of a problem that you always need to keep in mind when dealing with these models. So what is it actually that we're picking up on? Is it just usage, or is it, can we basically create an equation between usage and meaning? And that's a bit of a tricky question. So that's something that you have to be aware of in terms of bias. I don't know how that affects Christian. I mean, obviously that can affect Christian Latin specifically because as you've seen, there might be sort of different usages across texts that are Christian versus texts that are not Christian. But does that really mean that the word has or has not changed? Sort of these are kind of questions that you might need to ask. I hope that covers what you were asking about. But if you want to ask more questions or follow up, please feel free to do so.
Great, that seems like a great clarification. Thank you very much. And there's a quick follow-up question to that as well about exactly what your corpus is. So you mentioned that it was about 6.8 million words. Mm-hmm. Online, we've got the question, roughly how many books or texts is that? And could you tell us a little bit more about the texts that make up your corpus?
Yeah, so hold on. So I said in terms of like number of tokens, they were sort of pretty balanced between the two time slices. I think one of them was like 3.7 and the other one, 3. I don't know, whatever makes up the rest of math, which is 3.1. Okay, in terms of number of tokens. But in terms of text, I sort of worked recently on fixing some of the metadata. So I had a chance to stare, but I did that especially for the first half. So I think that was quite a good selection of both like sort of early Latin literature, like from comedy to I don't know. There was a bit of everything. Like if you go into a classic sort of literature course, you'd all of the texts would be there definitely. And I think the second time slice has quite a bit of a has lots of Christian texts. That was my point. So the second time slice has at first sight quite a high number of Christian texts, but then I found out to look into it a little bit more carefully that actually lots of these entries are books of the Bible, and so you see how that might skew up the numbers quite quickly. So if you're wondering, yes, all of the Bible is there. But yeah, I mean, if you want, I can try and pull up an Excel document with all of the text there, but maybe that's a bit too much for the purposes of today.
Well, I mean, where are you getting this corpus of text?
It's a corpus of Latin called Latinize, and maybe Barbara can tell you a bit more about that because she created it.
Yeah, so it's a corpus that was created from the Intratext digital library back in 2011. So it contains, as Valentina said, a range of different texts, and I then incorporated some other sources, but there were some duplications. So it's mainly really Intratext, and then it was lemmatized and part of speech tagged automatically, and then partially corrected manually.
Everything that's on the intertext digital library, it's a selection from that.
It's a separate thing. Sorry, you said the Latin.
Like, I'm vaguely familiar with intertext digital library. Did you just take everything that's on there, or did you do a selection on some principles?
So the original Latinized corpus was basically the whole of the Latin portion of intertext.
Okay.
And then, of course, Valentina made a selection that she explained earlier about the temporal cutoff.
We also have some text from like poetry source, right?
Yeah, so it was Musisque de Acque. Is that what you meant?
Yeah.
Yeah, so I integrated with Musisque de Acque and Lacus Curtius.
That's where most of these sort of early Latin stuff comes from.
So, if I may ask, what's the barrier to using the REPL's library text that you can? Is it because it's proprietary?
But I think this is all free access.
Right.
Yeah, that's why.
So, okay.
Yeah.
And you're not using any epigraphical material.
No.
Right.
Yeah.
Thank you.
There's basically nothing there that's epigraphical.
I can ask more questions, but
any more questions from anyone else in the room or online? So
I do have a question, but it's very vague. So I would be completely undisappointed. That's a horrible word. If you just say you can't answer it, but I'm thinking about the examples you showed us at the end of the sort of neighboring words in 3 clusters that we couldn't really figure out by looking at them what was going on. I'm thinking about the broader issue of these patterns that are thrown up by effectively algorithms that that in some cases we can say, okay, I can see why they've done that, or I can at least see some pattern in the pattern, and others where we can't see the pattern. Does that bother us? Does that bother you? I should ask, I suppose.
Yeah, no, I mean, yes.
If we don't know what's
obviously it
going on.
Yeah, it bothers me, and I'd like to sort of think more about why that's what we get. I mean, some hypothesis that you could come up with is it just depends on, I don't know, maybe these words are essentially a unique near. Maybe these words are coming from or appear in different text types, and so we're sort of picking up on neighboring words that are slightly different, but in fact, even though the same sort of type of discourse appears in different text types, the neighboring words end up being virtually the same, if that makes sense. That's one possible answer, but I don't know if it's any good. And I have no way of verifying it right now. So
I mean, I'm not thinking so much necessarily just of the cases where we can't figure out what.
Oh, like you mean in general,
just
like
in
you
general,
get numbers spit out and you don't know what they mean.
And that doesn't necessarily map to to maybe a slightly more traditional way of analyzing something qualitatively. Is that does that introduce a level of discomfort at all?
Yeah, I think so. I mean, if you come from a humanities background, especially, I think you'd like to match these digital technological results to what you know to be true. I'm not sure I can say much more than that, but it'd be good to. I feel like it's also good reason to look into these methods, right? Because you want people who aren't just computer scientists just to throw data at things and models and see and wait what happens, but also like people who know and have a background in this kind of material to be able to judge if these numbers that the algorithms spit out make any sense or try to make sense of them. I don't know if that's what you were expecting. But
no, I just wonder, is part of the answer that these results that you're getting back from the tools are the beginnings of new questions for you to analyze, rather than answers that you just take.
So you're trying to say that maybe these tools are revealing something else that we haven't seen. Is that the idea, or I mean, it could be that, or it could be that we don't understand the tool, or it could be that the tool needs improving. Like it's one of those.
Yeah. I would think that when you get something unexpected from the tool, that's when it's interesting, because that's when you when you look at it more closely and try to figure out why.
Yeah, and I think they do trigger more questions. It's true around, for example, what's the relation between usage and semantics, and different layers that these methods capture. Is it grammatical? Is it lexical? Is it pragmatic? Is it something else? So yeah, in that sense, I agree, and there are more questions coming up, but I think it's part of the discovery process, and that's also why I like to blend the different methods: collocation analysis, static embeddings, contextual embeddings, large language models, because they do work differently and they do help us pick up different things. Whereas in the sort of the traditional philological sort of a qualitative analysis, it's all together in our brains. So they all, and then of course we're very good at distinguishing, but also a lot of the sort of more traditional way of analyzing data is in a way implicit, and so we are forced to make the process more explicit this way. Thanks, very good question.
I have a sort of related question about the sort of choices that you make in the methodology as well. So obviously the examples that you chose, Oratio and Deus, to talk about today are examples of words that you really expect to be, that you already know from your knowledge of Latin, that they have a particular Christian meaning.
Yeah.
So how many words are you going to try to do this for? What's your sort of process of selection in what words you want to see, what you're interested in?
Yeah, no, so I mean, I think my initial approach is just to, say, maybe not very useful, but I want to sort of try and see how these methods work and contribute to sort of improving or understanding how to use them specifically for Latin languages that have a similar sized corpus. So my idea was just to look into words that we know to have changed meaning somewhat, and go from there. And some of them do show a change, and some of them these models don't really pick up on the change, and it might be because maybe there isn't enough data that show that change, and so that shows that, okay, yes, we still need to do close reading for the cases in which that one word, like, yes, changes meaning, but that meaning is not very widespread, cases like that. So I think my approach was, for now, is just trying and understand what we can do with these methods and sort of make them more targeted to Latin. But it's an interesting question, and I thought about trying to use it on just some random words, and I occasionally do, to see what they pick up. But as a way to make it more targeted for now, I'm working on words that we know have had some change.
I have a kind of I don't know if it will make sense or not, but will this entire methodology also work for other languages other than something that's written in the Latin alphabet, is what I mean? Because I obviously don't work with Latin and English. As a side quest, I work with Sanskrit, and Sanskrit is written in Devanagari script. The script is completely different over there. Will this entire methodology work with that, or should I have to transliterate everything and then?
Yeah, that's a good question actually, but I'm not entirely sure. I've never tried. I think there are some studies that sort of use Sanskrit and some of these technological tools. I'm not sure about embedding specifically, but like stuff like WordNet and stuff. I don't know if they transliterate everything or not, though. My assumption would be yes, but I'm not so sure. I don't know if you know anything about that, Barbara.
No, I'm sorry. No.
Yeah. I don't know. I would bet on transliteration more, but I'm not sure. Yeah, I'm sorry.
Technically, there shouldn't be any more of a problem
Okay.
working with the Devanagari script than there is working with Greek script.
Yeah.
So if you can work with Greek, then you can work with anything in Unicode.
Yeah, that's true. Yeah, as long as it's in Unicode, that's kind of a problem.
Which Devanagari?
Okay, that's good then.
Can I ask about a specific slide?
Yeah, sure. We can go back to those.
It was 28, if my memory serves. And I mean, I don't work in this field and I don't fully understand what's being said. So we have the word deus, and we have a list of adjectives and nouns.
Yeah.
And then we have 4 columns. What are we saying about these adjectives? Just forgive me, I understand that
Yeah,
you
no,
explained
that's okay.
this, but
So
what are we saying about these adjectives? and nouns
These are words that whose vectors appear close to the vector for deus. So what we're saying is that, I mean, the only thing that we can say about these words is that they appear in similar contexts as deus.
Okay.
So how you interpret that linguistically is a bit more fidgety, because what does it mean? Like, it can be words that tend to appear next or like with it, or it can be words that you consider synonyms. But sometimes, occasionally, you get words that, or like adjectives, but it can be even opposites as well. Like as long as they appear in a similar context.
So you think that's great. So it includes both words that are going to appear with deus, but also words that will appear in sentences that say the same kind of things,
Yeah.
the same terms.
Yeah.
Okay, the thing that's so helpful. Now, can I just ask while we're doing this about your because this caught my eye that you've got non-Christian texts. This is between 150 AD and 600 AD, right? Yeah. And non-Christian texts apparently use deus in similar contexts to the words Christus, and that's the one that really bugs me. What are these non-Christian texts that are talking about Christus a lot?
Yeah, it's a good question. I would need to go look into the corpus. So I'm not sure I can answer that off the top of my head, but
something, basically.
Yeah, there's something there. I'm not sure what.
Because I mean, the number of.
I mean, if you think about the
context,
that's good. That's a good. I don't know. What about, I don't know, some. I'm just like, just going wide here, opening my mind. But like, what if you had some, I don't know, legal regulations about how Christians can behave or something like that?
Well, I mean,
you might have.
Then you probably.
There.
I mean, if you're classifying material from the codification of Justinian as non-Christian, then you've got a problem because it shouldn't be.
Yeah, that's fair. Yeah.
So I mean, just on the technical point, then, are you able to? Sorry, I just don't know the statistics, but can you sort of get into the back end and work out what these passages are, where it's finding?
Yeah, I can do that. Just not immediately, but
no,
I can. Yes,
you can do that. Right?
Yeah.
So it's not just the black box.
No, yeah. I've got for some of the work that I'm interested in, I sort of printed off some concordances, so I can sort of look up where the word is, and yeah, I can go check these instances.
I would suggest you pull that one up. Something is going on.
Yeah. I just haven't sort of memorized all of these.
No, it's fine. I just wanted to understand. Thank you.
I was also slightly surprised by this slide and the similar one for, I think the similar one for RQ, but this one illustrates it fine. So the two columns on the right are the two subsets of the same corpus that's giving us the second column.
Yeah.
And yet the words appearing in them are sometimes completely different.
Yeah.
So the most common word in the non-Christian text doesn't appear at all in the six most common words of. And so I wonder, is that expected? Is that expected that the
Oh yeah, that's true.
Just because of the way vector math works, that you would just get totally different
as you
things?
can see, sort of the frequency is heavily skewed towards Christian text, so the word appears way more often in Christian text than it does in non-Christian text.
True.
And so that's gonna sort of skew the results for the whole picture of the second time slides quite heavily. That makes sense.
But it's also, I mean, Christus doesn't appear in the Christian text in the top 6 anyway.
Yeah, you're right. I don't entirely know why. But.
The frequency, sorry, is it a quantitative? I mean, we're saying, forgive me, I know this is confused, just not to me, but if I say, just so there's just the sheer number of times, or what are we comparing?
Yeah, literally all of the occurrences in that time slice in the corpus of, within Latinized, or the section of Latinized that are used. That's sort of the count of times.
So why is it a decimal?
Oh, no. Okay, those cores, that the frequency is sort of in brackets in the blue slots, right? But those numbers there next to the words, there's something completely different. That is the cosine similarity between Deus and that word. So how similar in a way, semantically similar, or is their vector.
Okay, so I get that. So what does the frequency number actually at the top in blue actually mean?
So that's how many times Deus appears in Latinized in the time slice 300 to 150.
So, sorry, because it's 6 words, but 1 number.
But the frequency is the frequency for Deus, not for the other words.
Oh, okay. Okay. And then
just to give us a sense.
Okay, sorry, can I just turn that back?
No, that's fine. Sorry, I didn't explain this.
And then each of these words are being classified by, because those are descending numbers for the vectors.
Mm-hmm.
So we're saying.
I'm putting obviously like in order of which one is the closest vector. Right.
So Dominus is the most, can I say semantically similar? Is that reasonably close to the vectorially similar? So the word could appear only once. It could still be at the top of the table, is that right? It doesn't have anything to do with how many times it appears, it's just how similar it is.
Yes, but I mean.
But at least it wouldn't have to appear very often.
This kind of came up in my mind as well. If at all there is a word X and that appears just one time, and that one word is very similar to Deus, and that's just appeared like 1 or 2 times. It can can it still be at the top because the cosine value will still be the same? Am I going wrong?
I think that cosine similarity doesn't consider the frequency of those words.
No, no, it doesn't.
Sorry.
Other measures go to, like, for example, Euclidean distance, but the cosine distance really just looks at the angle between these vectors, and so it's independent of the frequency. Yeah.
Okay. So that might be why you have Christus in your farming column. It's just there's 2 or 3 instances that somehow look a lot like instances of Deus. Doesn't.
Well, thanks for going into this.
Not much harder to figure out what these tables are telling us.
Yeah.
Thank you. Sorry to harass you.
No, this is useful.
Great. Any further questions online or here in the room? If not, I have one final question, which I think I've sort of asked you before, which is, do you think there's a sort of optimal type of word for doing this sort of semantic modeling? You said a bit that perhaps there's an optimal level of frequency where something is not too frequent or too infrequent, which is perhaps why your ratio gets a clearer results than Deus. But do you think it also matters for the type of word? So are you more likely to get clearer results from, say, a noun than a verb?
Yeah, that's a good question. So I wanted to sort of assess it qualitatively, like I haven't done any rigorous tests, but yes, I think normally you get better results for nouns and adjectives than you do for verbs. I'm not sure why.
You do all the case forms.
Well,
like when you're doing
I mean, because
Yeah, so I've lemmatized the corpus, so you don't get any different case forms, just to reduce variation.
So they're all mandatory.
Yeah, what I noticed with the, sorry, Barbara, go ahead. I'll go.
Yeah, I could just jump in and say, we haven't done a systematic analysis, but the expectation in my experience is that highly polysemous words can be difficult. Completely monosemous words are going to be sort of also on the extreme. So we are looking at the right balance between, you know, a few different clearly defined senses. That's where we're these methods are gonna perform probably best, because they, you know, you'll see clusters more clearly defined. My suspicion is that verbs are trickier than nouns, because you get, you know, all these extra phenomena like argument structure, telecity, you know, voice.
I did notice, yeah, I did notice that, you know, if you try and plug in a verb in this, like at least like it picks up, like, or if you try and calculate which ones are the nearest neighbors, they will all be verbs. So that's good. I mean, not all of them, but like overwhelmingly, they will be verbs. So, you know, the fact that they all tend to appear in the same or around the same grammatical categories, I suppose, is that's picking up on. But yeah, otherwise it feels like it's harder to judge the neighbors in terms of semantic similarity. Yeah.
Great. Well, thank you very much, Valentina and Barbara, for this excellent paper. We've got lots of comments in the comments as well about how this is a great talk, a fantastic paper. Thank you very much. The next seminar will be on Friday, the 11th of July, which will be Thibaut Clarisse from INRIA Paris on distributed text textings for digital classics. So see you then. Thank you very much, everyone.
Thank you.
Thank you. Bye.